The area clearance strategy form includes a parameter called area filter. Now, it is extremely important that we understand what this area filter does and how it works. If we take the example headlamp mould on the screen and we rough out this part without using the area filter, first of all we'll set the translucency of the model so we can see through and get a better look at the toolpath. You'll notice that at the bottom of the headlamp there are two small pockets which are just big enough for the tool to go down into. Now, PowerMILL by default, with the area filter switched off, will try and machine as much as the part as possible that tool can actually reach into. But let's say, for argument's sake, that the tool that we have used is not a center cutting tool. Typically when we're roughing out parts we're using larger tools which are carbide tip inserted tools. These tools do not have the facility to cut on the center. So the situation we have in this example is that because the tool cannot move in X or Y enough to clear underneath itself, we get left with a piece of material underneath the tool. This is not a problem for the current level that we're machining, but when we come down to machine the next lower level, then the underside of the tool will foul against this uncut region from the previous level. And obviously this is potentially dangerous for the tool and for the part, for the cavity or the mould. So we need to make sure that when we're using non-center cutting tools that we use the area filter to remove these small pocket regions which could potentially damage the tool. So we're going to switch the area filter on and we're going to use a value of 0.625. Now the value we put in this form depends on the geometry of the tool. To calculate the smallest value we can use for the threshold, which is defined in tool diameter units, then we simply, to work this value out, we simply divide the flat portion of the bottom of the tool by the overall diameter of the tool. So in this example we have a tool diameter of 32 millimeters, but we have a tip radius of 6 millimeters. So the flat portion on the bottom of the tool will be 32 minus 2 times 6. So that equals a flat portion of 20. If we then divide this 20 by the overall diameter of 32, gives us a threshold of 0.625. So by using that value we can be sure that the tool will not go into areas where it cannot machine away underneath itself. So there we can see the result of using that area filter. The segments in that small pocket at the bottom have been removed. Now the only thing to be aware of when using this area filter is that by setting the lead-in move to plunge, this will effectively override the area filter and switch it off, because PowerMILL assumes that because we have set plunging, then the tool can plunge into material and is a center cutting tool.